All right, afternoon, everybody. Thank you for joining in. So the talk this week is going to be from, I'm going to mess up your name, Fabio. Andrijauskas.
Andrijauskas.
Okay, well, thank you for correcting me. The talk this week is going to be on the Open Science Data Federation and ESnet. And Fabio did let me know that if people do have questions, certainly raise your hand. And I've left the ability of you guys to unmute yourselves. So if you have a question during the talk, just identify yourself and I'll call on you. And Fabio said that he's going to be doing this talk as well as a little bit of a demo. So I'll turn it over to you, Fabio.
Thank you so much, Jason. And as Jason said, my name is Fabio Andrijauskas. I'm working in the UCSD, specifically in the San Diego Supercomputer Center. And my main task is to take care of the Open Science Data Federation. And we have a tight relationship with SDSC. We have at least two major caches in Europe. And I would like to talk about what is the OSDF and how the ESnet integrates and is part of this data sharing process. Okay, OSDF, Open Science Data Federation. The Open Science Data Federation now is using the Pelican platform, is a orchestrator of federations, of data sharing federations. And basically, the Pelican uses and has major components, but there's two main components. One is the director, is a part of the software, lives inside here, and is responsible to direct requests for files. I will talk about a little bit more about this later. And we have another component called registry. When a cache or a origin start running, he needs to go to the registry and say, hi, I am this origin. I'm going to provide this namespace, or I am this cache. I'm going to provide this namespace. With the Pelican, now you're using mostly the Extrude as the engine to provide the data. Then you have the Pelican layer, and you have the Extrude doing all the data directly jobs. But with Pelican, we can provide an Extrude. We can provide data from different places. We can do a POSIX data sharing, like a classic one, just a mounted directory, could be any background and can provide this data. We can provide data from S3. You can provide data from Globus. You can provide data now with a new layer from Pelican, from a simple SSH connection, and can provide this data as well to the federation. And the federation has several caches to speed up this process of data share. To access this data is quite easy. Use mainly HTTP requests, and you can request a file using the Pelican client, or you can request a file direct to the director, and the director going to do the magic. But what magic we talking about? We have different caches all over the place. We have a few caches in Europe, in Europe, in America. We have a few caches in Europe. The one in India, a little presence here on Singapore is a huge cache, this one. And ESnet caches, they are here in Europe. But the magic we need is to request a file and try to get this file as closest as you can. Just example, if someone is running or requesting a data to the SDF from Europe, we don't want this data going to be travel all over the ocean to provide this data here in Europe. We want to go to the closest cache or the most available or the closest. That is two different things, but we try to create the first strain, say, okay, we're going to try to get the data from the closest one. And that is the director, that's part of the director, what he does to provide his data. I'm gonna try to run. Can you see my terminal? Just to be sure. Can somebody confirm, can see my terminal, please?
Yes, we can see it.
Thank you. And on the SDF, we have the Pelican client, and we can request the data using simple verbs, object, get, and you can request the data from a specific namespace and just access it. we don't need to, we can use the Pelican client, but you can use just directly HTTP requests to the director and get this data as well. And here I'm in Madison now. If I request this data, there's a bunch of stuff, but basically he tries to find the closest cache. He creates a list here with the closest, and in the end, he figured out the cache in Madison was the closest one. That's good. And you get this data from the closest cache. This is not just the closest location. There is a more statistical approach for this, because if you're just getting all the time the closest cache, we can overload this one, and then it could be a problem. That's why we have the closest directive, but we have more statistical one saying, okay, could be the closest, but could be another one is not that close, a little bit far away, but you try to do a load balance in this process. You can upload data, you can download data, can list the data. Uh, on the SDF, the data is immutable. In this way, you cannot change any data because you don't do any cache coherence process. But if you need to put a new data set, you just can change the name of the file or the name of the directory, and that's going to be a new set of data. Then we don't need to change all the information of the caches. We just figured out this going to be a new set of data. Of course, you can create this feature, but cache coherence is a problem, and this problem is is very well known in computer science. Sometimes it's just okay, it's very easy, just delete all the files in all the caches, and it's done. Then you can we have cache coherence. When you start to think about a little bit more, it's not that simple. With the Pelican, we have a web interface for each cache and each origin, and it's quite useful, especially when you need to debug information by email. You can just ask the administrator if everything is green. That's could be sounds silly, but it's very useful just to ask the administrator, okay, can you log in your origin, your cache, and figure out if there is something wrong or not. With that, you can figure out and debug not all the problems, but at least you can say, okay, it's not working or what's going on. Besides, with the director, we know when a cache or origin is in trouble, then you can just from the central service, you can figure out not figure out directly, but you can say, okay, this cache origin is not okay. One very important aspect of the director, the data don't goes to the director, just a request. Request the data to the director, and the director redirects you to the closest cache. Or if you want, you can go direct to the origin, but normally it's not a good option. The data don't need to go to the director. Then the centralized service is most control, not the transfer. That's very, very helpful in this kind of scenario. As I shown, this is the transferation here in slide, just picking the three closest cache and going to the cache he thinks is the closest, but could be with less load or less IOPS. There is a set of things you can figure out. When you need a new cache, we have major three models to install these new caches. The first one is RPM installation. Then the administrator just go to the node, we have a repository, install the packages, and make the configuration. That's the first aspect to do. The second one is a local container. We do have Docker images, then you can set up these Docker images and just pass the configuration, just use the local storage and set up a cache or an origin. And you have one thing called NRP, and I'm gonna talk a little bit about what it is. The NRP is the National Research Platform, and basically is a giant Kubernetes service running. Just gonna show the map real quick, but we have hosts all over the United States, a few in Europe, Brazil, a few in the Singapore and others, and is a giant Kubernetes cluster with different kinds of capabilities of GPU, CPUs, storages, can be used to process data, can be used to do literally research, not just data sharing. One interesting thing for NLP, we do have some LLM models you can use, and it's free. Normally, we just need to be associated to any institution in the US, then you can have access to NRP. And we have LMs for free. Then we just can go there, log in, and use the models. We don't need to pay. And people just literally run simulations and other processes into NRP. In my case, I run all the OSDF caches and origins into NRP. Not all, especially the ESnet. We have some integrations things related to NRP that could be sometimes a problem. Not direct a problem, but I'm gonna show to you how we need the node to be configured to be part of the NRP. And when the node is NRP, for me is easier because I have assistant for deployment and I just deploy the services. When what I need to integrate a node into NRP. Some things are easy, public IP, IPM access, host access, and the firewall is controlled by NRP. Basically, when we integrate a node into NRP, we just give access to everything to us and you set up everything. And we just need to keep the machine working, just need to keep the network and the machine working. All the system administration is made by the NRP team. I'm pretty sure a lot of you guys could be from the security team or something like that, and this idea could be a little bit ambitious or something. But we do have several nodes running this way, and it works. We don't have any major security problem or something related to using a third-party firewall, but it's a little bit complicated when you think about the security-wise. On the ESnet nodes we have are not integrated into NRP. We are using a Docker image, and the local admin take cares. When I have some problems, I ask the local admin to fix it or to figure out with me what's going on. On the NRP, we have the GitOps Kubernetes integration. We just set up the configuration into GitHub, and this GitHub go to Flux to NRP and deploy the services. It's pretty useful because if I have any problem into the NRP, into the cache or origin, anybody in the team could figure it out and try to fix it. It's not something is related to a cluster, but this one doesn't count to the ESnet caches and origins. By the way, 2 caches. We do have a monitoring system to figure out is a cache working or not. And we do have one in the registry and one in the director is related to all the central services, but we have external one to make sure everything's working. We have different testers for each cache and origin, trying to figure out if the cache is working or if the origin is working. Talking about the ESnet caches, we have 2. One is Amsterdam. It's a very important cache to us because it's used for, of course, it's Amsterdam. It's mostly used for the European OS pools and other projects. And the last account I did, it saved at least 50 petabytes of information. Do not travel all over the ocean and just stay here. All the caches are filled up in demand. That means when someone asks the information is not the information is cached, and the second request is going to be directly to the cache. The Amsterdam one is a very interesting because we do have the Amsterdam University and other places using this cache is very, very useful for this area. And we have the London cache. It's not that far away, but in Europe, the SNet caches are the major ones providing data for us. Because the London one saved us at least 16 petabyte of information. And who using that? Who using this data? Which namespace have been used for these caches? Mostly US legal and more legal. That's the main users from this project. So we have another cases here, but mostly we have the legal collaboration processing data and using the caches. And we have these hosts here accessing the data. Could be interesting to know which university is accessing. Mostly is SURF accessing data, but we have different institutions using the caches and using the information provided by the OSDF. Here we have another count access from each host. Then we have different hosts here accessing the data, providing using the cache. And one very interesting thing, we don't pick the cache. You just go if you're in Europe, we're gonna pick the cache for you, and again have been used for a very specific time. And in the very end, we saved at least 20 petabytes of information for the caches. 20 now, the last calculations are not ready, but the new number is going to show, at least considering the 15 time span, probably 40 petabytes of information that does not need to cross the ocean, is going to be locally in Europe using these two caches. The SNet is a wonderful network providing a very interesting pathways of data, and sometimes could be interesting to figure out new caches all over the place. And I'm always happy to help to the to do the installation. We have some OSDF publications related to operations, best practices, some use cases, and other information about how we use, how data is transferred, and other information related to the Open Science Data Federation. Basically, this.
Well, thank you for going through that. Does anybody have any questions that they'd like to bring up? I have a couple that I had written down here. So what's the process for somebody who would be interested in trying to host a cache? What do they have to do to do that?
We do have our website saying the minimal specifications to host the cache. Normally, we need a network at least 10 gigabytes, mostly sometimes 40 gigabytes. And for the cache, we ask to have a storage SSD type-wise, because without that, the cache could be could be a little bit slow to provide the data. But basically, connectivity and fast network and fast storage to provide to create the cache. All the installation process and all the configuration, everything else, I can help. There are other people as well can help to do the process. We just need to have an interface and figure out how to do it.
Okay. And you said that it requires a 10 gig connection. What's sort of the background load of any individual cache at any given point in time?
What do you mean?
How much additional traffic would that put onto somebody's network if they were hosting this?
Yeah, that depends. How close the cache is from a West Pool or a cluster or something like that. Is sometimes it happens. I think twice someone said, "Okay, Fabio, we're turning off the cache because you use the whole university bandwidth." Sorry, but depends a little bit with the project is running. If some projects are literally doing runs to analyze some data, it varies by time.
Okay. And I'm assuming that there are probably ways to balance the load between these different cache instances. So if somebody was noticing that they were getting a lot of traffic, is that something that sort of OSGF would be able to sort of help with to make it a little bit less popular, or is it something that's very dynamic?
No, you can we can't we have some knobs you can turn if a cache starts to being too overloaded. We have some basically you can say how much the cache is available. You can put this number down and it's going to be less peak when someone asks the data.
Okay. Does anybody have any other questions they want to bring up?
Can you show the geographic map of the continental U.S. again?
Which one?
The U.S.
Yeah, the map of the U.S.
Oh, the West.
So I'm
For
from
the inner.
Illinois, and I'm curious what's the closest cache. There
Oh,
might be one in the ESnet office here.
let's see. I think this one is gonna be a little bit complicated to see. Let's go to the website. You can just zoom in. Okay, which area?
Chicago area, south of Chicago. Yeah. Okay.
Got it. It says okay. Sometimes I get lost in the US map, but it might be. Yeah, we have this one in Madison, but we have I think one or two in Madison. We have in Chicago one, and you have Notre Dame as well.
There you go, Davey. You can host one at NCSA.
Where I'm going with this. Out of curiosity, just considering options. Thanks.
All right, and Michael typed in the room. Oh, okay, yeah, there's not one in the ESnet office.
Oh yeah, that could be a problem. Need to figure out how to start one.
Just get a 100 gig link into the office.
Is there any spare computer you can install? I'm kidding.
Well, we know the people to ask. All right, does anybody have any other questions?
It'd be interesting to have a ESnet cache in the US because we don't have it. We have it only in Europe. Maybe one here could sounds very appealing.
Well, I'll leave that up to Alex to bring up the ESnet management since I know he works on that project.
A little fishing.
All right. Well, thank you so much, Fabio, for going through that. If you want to send me a copy of these slides, I'll make sure that they get posted along with the video. And just as a programming note, this will be the last talk for the summer, basically. We don't have any talks scheduled until August again. So if people do want to encourage their colleagues to come and give talks, certainly that would be good. Otherwise, we will have another one in the August timeframe with the Persona group. So thanks, everybody, and we'll talk to y'all soon.
Thank you. And I'm available by mail if someone needs something, just let me know. I'm
All right. Thank you so much.
willing to help. Thank you so much. Bye-bye.